This is Brian Jakovich, and welcome to Stelligent Screencasts. In this screencast, I'll be going over adding an elastic load balancer to an autoscaling group using CloudFormation. I'll just add to our previous template that I built in the previous episode where I went over IAM roles and users. That was episode 6. So an elastic load balancer, which is often referred to as an ELB, is a great way to help scale and improve the fault tolerance of your application. With an ELB, you get several features that separate it from using something like F5 or your own personal load balancer. The most important is the integration with autoscaling groups. With an ELB and autoscaling groups, you're able to have your autoscaling group connect to your ELB, and then when it scales instances, they will automatically get added and removed from the ELB's fleet. So in this diagram, let's say these are all of availability zones in US East. So it'd be availability zone A through E. If the instances in E were to go down and become unavailable, the elastic load balancer would work with autoscaling and only direct traffic to these 4 while they're currently in service. And then once US East E comes back into the autoscaling world, where autoscaling scales it and then it becomes available again, it will automatically get added back into the elastic load balancer. There's no external configuration you need to do to it. It just works. It's really easy and really nice. Without an ELB or a load balancer in general, the autoscaling will more or less act as a DR solution, so that if an environment were to fail and the instance were to go unavailable, autoscaling would just replace it. It wouldn't connect into the ELB, and you wouldn't have a single endpoint to access all of these instances. So an ELB is a load balancer. However, the added benefit that gives your AWS environment is the fact that it connects to autoscaling. So it's fine to use autoscaling in the way that I was mentioning, where it's a DR solution, but the preference is that if you can use groups and connect them to an ELB, that's a preferable option. However, you do need these applications to be stateless, otherwise everything's going to get messed up. Application architecture. So to build the ELB, I'm just going to go in the resources section, template right next to our web server autoscaling group template that I episode 6. So what I'm going to do is I'm just going to create an elastic load balancer and then give it the type of elastic load balancer. Okay, so there's the load balancer. Then I need to add some properties to make this unique. So I'm going to add availability zones, listeners, and health checks. Okay, so now we have the 3 options in our properties. Availability zones, you may see that I have availability zones defined here and availability zones defined here. I will be connecting the autoscaling group with the elastic load balancer, but these are have different meanings. When you define availability zones in the elastic load balancer, it defines where the elastic load balancer will be sending requests. So if you have instances in US East A through C, and inside your load balancer you only add the availability zones US East A and B, it will only direct requests to US East A and B. So the US East C won't be receiving requests even though it's in there. Whereas the autoscaling groups define where the instances will be launched. So if you were to define the availability zones A through C, it will launch up instances into A through C, regardless of the fact that the load balancer would only be directing requests to A and B. So that's just a little bit of information about what the difference between availability zones and the autoscaling group availability zones. What I am defining here is all availability zones using fn get AZs. Next we have listeners, and listeners determine ports and protocols the load balancer will use. Then there's health checks, and a health check is used for the load balancer to determine which instances in its fleet are healthy enough to handle requests. Will check the instance for a 200 HTTP request, and if it returns a 200, it will deem the instance as healthy. Otherwise, it will consider it unhealthy and remove it from its fleet. So I do want to stress the importance of it being a 200. Anything other than a 200 will result in the instance being marked as unhealthy. The most common annoyance of this is the redirect. So if you have a redirect that eventually gets to 200, it won't care. It'll see that there's a redirect and fail. So to give a kind of an example of this, of an issue that I've had, I tried to use an instance :8080/Jenkins without a trailing slash for like the target of my health check, and the Elastic Load Balancer wouldn't recognize that this instance was available, despite the fact that I could go to it in my browser and it would work. And the reason why is that there was a trailing slash that it needed to get to 200. So it was redirecting when I didn't include the trailing slash and redirecting to the 200, but because the load balancer didn't know that, it was failing and wouldn't mark the instance healthy. So I spent plenty of time having that problem. So I'm just going to go ahead and add some listeners and health checks, and we can go from there. Yeah, we have our listeners and our health checks are fully written and configured. So I'll just go over each of them. The listeners, I'm saying the load balancer port 280, so that's basically the port that the load balancer will listen on. Then setting the instance port to 8080, so that's the instance, or that's the port in which the load balancer will be sending requests to the instances. Check, I'm saying the target, and as I was describing before, this is where you specify where to get your 200 request. The IP, the 8080, and with trailing slash, and that will get our 200. Then the healthy threshold. So what this means is that it will try to ping the target and look for a 200 3 times before it marks the instance as healthy. So if it gets 2 and then it fails, it won't mark it as healthy. And then the unhealthy threshold is 5. Basically, the Elastic Load Balancer will be continually pinging these instances to make sure that they're deemed as healthy for the load balancer. So if it sees that the instance doesn't reply with 200 after 5 times, it will mark it as unhealthy. It will look every 30 seconds, and then it will wait 5 seconds for the request. So now we have a fully configured load balancer. It'll be listening on 80 and then directing to instances on port 8080. So the next thing we need to do is connect our auto-scaling group to our load balancer. And this is just a simple one-liner, and it's really easy to add into your auto-scaling group configuration. And that's it. Our load balancer is set up and our auto-scaling group is configured to connect to it. So let's launch up our stack and start deleting the Jenkins environments to see it in action, so that when we destroy an instance in an auto-scaling group, it will reconnect to our load balancer. One thing I realized is I need to make this an uppercase as to lowercase, so load balancer. It's just a syntax error that the AWS CloudFormation is going to complain about. Okay, now our CloudFormation template is completed and we have an Elastic Load Balancer. And as you see here, we have 3 available instances because the auto-scaling group is up with 3. Now what we can do is we can go and try to go to our load balancer and see if we can access it. So let's click here. And there we go. We have a Jenkins environment, one of the instances themselves. So the instances are being used by the load balancer. What we can do now is delete an instance and see if it works. The load balancer continues to direct requests. So I'll just go ahead and delete this one. In fact, I'll delete 2. Okay, then we can go to our load balancer and see if it still works. There we go. It's still up and running. even though the instances behind it are deleting. Now, autoscaling will start replenishing these instances on the back end. Like the load balance will continue to use this one instance, and the autoscaling groups will notice that instances have gone down, and then it will start to replace them. They will then just be listed back in here in our instances section as the new ones come available. So there's nothing you need to do, and it just automatically works for you. If you like this screencast and want to get updates when new ones are posted, hit like and then subscribe to our channel. And if you have any feedback or inquiries, please email us at info@stelligent.com or tweet me with the handle @Brian Jakovich, Stelligent itself @Stelligent. If none of those work, just leave a comment in YouTube.